Guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics SPM trial paper for MRSM for the year 2021. And this is the paper 2. Let's get straight to the first question. Here we are given function fx equals to negative 4x squared minus 4x plus 2. And we're supposed to use the method of completing the square to express fx in this form. Okay, so the first thing is, if you want to complete the square, you need to ensure that the coefficient of x squared is 1. If it's not 1, as you can see, this is negative 4, we will have to factorize it. So I take out negative 4, right? So that your coefficient x squared is now 1. But when you factorize the negative 4, the negative 4 from the second term, we have to factorize it as well. So when I factorize, or in this case, you divide negative 4, you're left with positive 1x. And then you still have a 2 outside the bracket. Yeah. Take note that I didn't want to factorize all 3 terms. Some people will factorize all 3, but I think it's a waste of time because the 2 here is not involved in the process of completing the square. So when you complete the square, we just want to take out the first 2 terms. Now, next step is we'll take half of negative half of 1 here. Now, coefficient of x is 1. And I hope you know that the technique of completing the square is this. If you have x squared plus bx, we'll take half of b, in this case, b over 2, and we'll square it. Now, the thing is, when you square this, right, you have an additional term. This is 2ab and a b squared. Now, the additional term is your b over 2 squared. So we have to subtract this off, so that we are actually getting back the same thing as we have above here. So in this case, your p is 1. So you divide it. So it's 1 over 2. You square it. And then you minus 1 over 2 squared, which gives us 1 over 4. Now, I personally think this method is much easier than rather than, some will add and then subtract. Some students will take x squared plus x. Then they take half of it. They square it, then they minus it, and then they factorize it. So I think it's a bit slower, right? So I like to do it in this manner, right? It's faster, yeah, and it's easier to understand. Now, next, you take this negative 4 and you multiply inside. So it's minus 4, x plus half square. And the negative 4, when you multiply inside here, it will give us minus 1 plus 2, right? The minus, by the way, will give us a plus. Minus 4 times minus 1 over 4 is a plus. Then it's going to be a plus 1 plus 2. This is going to give us x plus 1 over 2 square plus 3. There you go. We have expressed in this form. Okay, second part, we have to sketch this graph. Okay, you will know how to sketch a graph, right, of quadratic function. The main thing is, the first thing is to identify the coefficient x squared. I can see that my coefficient x squared is negative 4, which is less than 0. So the graph is a maximum graph. So we say that your fx will have a maximum value of 3 when the one inside the bracket, x plus half, is now 0. Now, let me show you again. Your fx can only be 3 if the one inside the bracket is 0. So x is now negative half. Yeah, let me write here, x equals to negative half. Now, it's important that you identify the turning point, the maximum minimum point first. Then we do a sketch, right? We know this is going to be on the left. Maybe I add in an axis, yeah? So let me draw like this. Let me use a ruler here. It's better, more accurate. Okay, let me move this slightly to the right. Okay, add in another line, your horizontal axis. So it should look like this, right? Okay, now your x is now on the left. So I put a negative half. Your maximum is now 3. So this is your maximum point, right? So everything else will fall below. So we know when we sketch a graph, the graph should go up This is your maximum point. Come back down. Right. Now, the next thing is, we know that this graph will intersect the y-axis as well as the x-axis. So we have to find all the x and y intercept. Now we know at x-axis, your y is 0. Okay, so you can choose to start from here, or you can use this. I like to use the vertex form here because it's easier for you to solve for the root in the event that the root is not an integer, right? In the event that you cannot factorize directly, right? So sometimes you may have cert form, right? So we use this, is easier. So let's bring this to the right. I bring the -4 to the right, right? The whole -4 bring to the right, so it's +4. If you want to bring the 3 to the right, there'll be -3, then you're going to divide by -4, right? So this x plus half square is now 3/4, right? We know that in this case, you can't square root and get a whole number, so we leave it in the form of plus minus square root 3/2. So let's take this and bring over -half minus 3/2 and -half plus 3/2. So that represents the two roots that we have here. The -1 will be over here. The +1 will be over here. All right. Now, I also have y-intercept. Now, for y-intercept, I think it's easier to look at the original function here. The original function here, you can see a y-intercept is your c is 2, right? So we can say y-axis, your x is 0. Let's just put it back. You can write f0 if you like. Your answer is 2. So this is 2. Okay. So when it comes to sketching graph, remember, show that maximum point. This is your maximum point or minimum point. Your axis of symmetry, this is your axis of symmetry, x equals -half, your x-intercept and your y-intercept, and my graph is done. Now, let's look at part C. Given that point P lies on this graph such that RS, your y coordinate is S, S coordinate is R, such that S is more than 0. If the vertical distance of P from the x-axis is 0.44, vertical distance from the x-axis simply means the height. Yeah, maybe I just draw a line for you, maybe around here. The vertical distance from the x-axis will be this 0.44. Okay, so you have a point on the graph. The point can be here, right? And it's RS. So you're supposed to find the horizontal distance of P from the axis of symmetry. Well, your P can be here, Yeah, I just put a P and a P prime if you like. So we know the height is 0.44. So we need to find your x value and then find this vertical distance, either this or this. Okay, but because they're symmetry, they're going to be the same. So we just find one will do. All right. Okay, so let's start. We start by like writing your y or letting your y, in this case, fx here, -4x plus half square plus 3, let it be 0.44. Okay, so I'm going to bring the 3 over and divide by -4. You can use a calculator, right? Since 0.44 is not a nice number, 0.44, you minus 3, right? And then you divide by -4. So this will give us 16/25. You can leave it in decimal. All right, I'll just write 16/25. Yeah, so x plus half square is 16/25. So let's just square root this. When you square root, by right, you put a plus minus, right? So square root 16 is 4, square root 25 is 5. So it is plus minus 4, 5. Now, actually, you don't have to find x coordinate. You don't have to find x coordinate. This plus minus 4, 5 is basically this distance here. Yeah, 1 is smaller than your x coordinate by 4, 5. One is to the left-hand side. Yeah, 1 is to the right-hand side. But if you want, you can actually work it out. Your x value is, number 1, -4/5 minus half. Second one, +4/5 minus half. So, okay, I'm just going to show you here. -4/5 negative 4 over 5, you minus half, right? This will give us 1.3, negative 1.3. You can write 13 over 10. Maybe I write negative 1.3. The other one, I just change the negative to positive. So this is 0.3. All right. So that means that this is 0.3 over here. Let me use a red color pen. This is 0.3 over here. This is negative 1.3 over here. So, but your horizontal distance still the same. Your horizontal distance from the axis of symmetry, it is still 0.45. Yeah, whether it's to the left or to the right. So we can just write your horizontal distance is just 0.8, or you can put 4 over 5. Okay. Okay, let's move on to the next question. Question number 2. Question number 1 is the quadratic function. Chapter 2, this is chapter 3, system of equation. Okay, so the first thing is you are given a diagram consists of a square and a rectangle. So we have to form three equations actually. So the first thing is the sum of perimeter for both quadrilateral is 68. So if you add up, the perimeter for a square is x plus x plus x plus x, 4x. So we can say the perimeter is 4x. But for the second one, the rectangle is 2y and 2z. So you write 2y here and 2z here, and your sum of perimeter is 68, right? So number 2, I think we can simplify this equation. And for me, I can see that all these are divisible by 2. So when I divide by 2, I will get 34. Yeah, this will be your first equation. Okay, the second equation will be this. The length of rectangle PQRS, y, is 4 cm more than the length of the square. The length of the rectangle is y. Y is 4 cm more than the length of the square. So if y equals x, that means the length equal. But if y is bigger, you have to add 4 to your x, so that whatever x you have, you plus 4, it gives us the length y. Your y is 4 cm longer, so we can say y is x plus 4. That will be your second equation. So the third equation is this: the ratio of the width of rectangle, z, to the width of the square, which is x, is 3:4. So the width of the rectangle is z, width of the square is x. Now we don't write in this form. Not to say you can't, you can. This is 3/4, but straight away we can write in the form of proportion. But proportion are basically two equivalent fractions. So z over x must be equals to 3/4. So I think we can make z as a subject, right? So your z is now 3/4x. That will be your equation number 3. So we have 3 equations, solve it simultaneously. Now I think since equation 2 and equation 3, they are both written as a subject in terms of x. They're both written as a subject and they're written in terms of x. I think we can just straight away sub equation 2 and 3 inside equation 1. So then we don't have to write so many times, okay? So immediately, instead of writing y, yeah, when you sub inside equation 1 here, we don't write y, we write x plus 4. We don't write z over here, we write 3/4x. And this sum is now 34. Now, if you have fraction, you don't like the fraction, yeah, makes it complicated. So you just multiply everybody by 4. So this is 8x plus 4x plus 16 plus 3x. 34 times 4 is 136, right? You can't do it mentally, just use your calculator, right? So 12, 8 plus 4, 12, 12 plus 3, 17x, right? 12 plus 3, 15, sorry, 15x. And 136 minus 16, 16 I bring over to the right. I got 120, right? 120, if you divide by 15, x is 8. Okay, again, you can use your calculator. 120 divided by 15, result is 8. So once you got your x value, we just have to find your y and z, sub inside equation number 2 first. All right, your y is now 8 plus 4, which is 12. All right, if you sub inside equation 3, your z is 3 over 4 times 8. Answer is 6. Okay, so you got all three values. X is 8, y is 12, z is 6. Okay, moving on to question number 3. So, okay. So diagram shows a semicircular shape of a mini theme park with a center O and a radius of 16 meters. So the sector SOR is a ball pool section. Sector SOR, ball pool section, with the length of chord SR is 12 meters. So this is 12, this is 16. The ratio of length of arc PQQR is 3. PQ is 3, QR is 2. Okay. Now, and we're supposed to find the value of theta in radian. Okay. So now, if you're given the length of chord, okay, so I want to show you a formula for chord. I like to use the formula for chord. Actually, it makes your life a lot easier. Every time you have a chord is a line that cuts through a sector of a circle like this. Okay, so this is your chord. If you divide evenly at the center, this is a radius r, this is r, this is theta. So let's call this x. If you halve it, this will be theta over 2. So your sine theta over 2 is now x over r. If you multiply over x is now r sine theta of 2. Therefore, your chord is measured from this point to this point. Your rs, if you like, yeah, is 2x. Your chord rs is 2x, which is 2r sine theta of 2. So you can use this formula if you want, right? If not, you just do slowly, one by one, right? It's the same thing. Okay, so let me just show you one by one. If you want to find the length of angle theta here, you can see that if this is 16, if you divide evenly at the center, this will be half of 12, which is 6. So this is your 16. The whole thing is theta, half of it is theta over 2. This is rs, right? So we say sine theta over 2 is 6 over 12, 16, 6 over 16. So use your calculator. Now change your calculator to radian mode because we want the angle in radian. So I'm going to shift sine 6 over 16. So whatever I get here, I multiply by 2, right? My theta will be 0.7688, right? Theta is 0.7688. Okay, so once you got the value of theta, now, next, we're supposed to find the length of the fence. Okay, can you read the whole thing first? The question says that the yellow color fence area is a waiting bay for parents while their children play in ball pool. Calculate the length of the fence of the area. So this is the waiting area, all right? And the waiting area is basically this segment. So we are supposed to find the perimeter of your segment. So perimeter segment, in this case, since we already know the length of this chord, we just have to find or add in the length of arc. So your perimeter or the length of fence is given by the length of chord, 12, plus length of arc, rs, which is r theta. I know my r is 16. My theta is 0.7688. So we should just add them up. 12 plus 16 times 0.7688. Okay, my answer is 24.3. Yeah, 24.3 meter. 30. Okay, always give your answer correct to 4 significant figures. So this is for SF, right? I must say the marks given for first part is a bit too little. The marks given for the second one is a bit too much. Maybe you should put 2 marks here and 2 marks here. It's a bit more balanced actually. Yeah, because the first part here, you need to do sine and then to get the answer. Second part, you just have to basically find the length of arc at with 12 to get the perimeter of the segment. Okay, let's move on to part C. So you're finding the area of the children's playground. The children's playground actually is this part here, right? This is a children's playground. So a lot of people will look at this and say, hey, this is 90 degree. Now, please avoid thinking that because the question didn't say that it's 90 degree. In fact, they say that the ratio of arc PQQR is 3:2. So first of all, you need to find what is this angle, POR. Maybe we say POR is what? Since this is a straight line, POS is a straight line. It is a semicircle. So we can say it's pi minus angle theta 0.7688. But remember to use 3.142 for your pi. So let me use 3.142 minus 0.7688. Then my answer is 2.373. Now you want to use more decimal point, go ahead, 2.373, yeah, 2.373, okay. Now next, once you know angle POR, we need to find what is angle POQ. Well, POQ is 3/5. Let me write here, POQ is 3/5 of 2.373. Okay, so you can actually write one extra decimal point here to make it more accurate if you like. Then take this, multiply by 3/5, and this angle is 1.4239. Yeah, 1.423 is 1.424 is good enough actually. But if you want 1.4239, yeah, that will be angle POQ, because we need this angle to be able to find the area of this children's playground, which is what? Half r square theta. My radius is 16. I square it. My theta is 1.4239. And just use your calculator. Half times 16 square times 1.4239. There you go. I got 182.25. I think for SF, for the final answer is good enough. 182.3. 182.3 square meter. So this is Form 5, Chapter 1, Circular Measure. Let's move on to question number 4. This is Form 5, Chapter 6, Trigonometric Function. Okay, so here the first part, we're supposed to prove that cos square x divided by sine x plus sine x is now 2 cos x cosecant 2x. Okay, when it comes to proving, we start from one side, move towards the other. Let me start from the left-hand side. We always start from the side that with more number of terms. In this case, the one that have more number of terms is the left-hand side. Yeah? The number of terms is determined by the plus and minus sign. If you separate it by a plus or minus sign, it's considered 2 terms, whereas this is considered as 1 term. This one is 1 term, this is 2 terms. So normally we start from the side with more number of terms, work towards the other side. Okay. So what do I do with the cos square? I think if I start from the right-hand side, left-hand side, cos square, I think we have to perhaps combine this first. This sign doesn't have any denominator, so you have to multiply top and bottom by sine. Okay, maybe I write one extra step for you. This is sine. There is a sine x here, so you multiply top and bottom by sine. So what we have here is a cos square x plus a sine square x over sine x. Now, we know cos square plus sine square is 1 from the basic identity. Yeah, cos square x plus sine square x is 1. So we can just change this to 1. So it's 1 over sine x. Now, here's the problem. What do you do with this? Where do you go from here? Well, sometimes you may have to look at the right-hand side. Now, see where we're heading. Now, on my right-hand side, I have 2 cos x and cosecant. Now, we know that cosecant is 1 over sine, right? 1 over sine. but this is cosecant 2x, so it's 1 over sine 2x. And the formula for sine 2x is now 2 sine x cos x. So what you notice is that when you cancel this, right, and cancel the 2, we're actually getting the same thing as the left-hand side. But it's a bit hard for us to work from the left towards the right if you don't know what is the end result that we're finding. The end result that we're finding is 2 cos x and cosecant 2x. So you may have to work out this first from the right to be able to see the point where you can connect them. In this case, what I need is to multiply top and bottom with a 2 cos x, because I have a 2 cos x and 2 cos x here. So this is what I'm going to do. I'm going to multiply top and bottom with 2 cos x, 2 cos x. So let's keep the 2 cos x on top. As for the denominator, I'm going to write 2 in front, 2 sine x cos x. And once you got the 2 sine x cos x, well, we can just combine it and write this as sine 2x. This is from the double angle formula for sine 2x. And now look at the right-hand side. I can see there's a cosecant. So I bring it up. 1 over sine is cosecant. So I'll write this as 2 cos x and cosecant 2x. And therefore, this is the same as our right-hand side. All right. So please don't do left and right at the same time trying to find matching point. So that is not a good way of writing. So we always want to start from one side, work towards the other, right? Now, when you're getting stuck with certain step, like when you reach until 1 over sine, don't know what to do, you can actually work out the right-hand side and see the matching point. And after that, you just continue working out towards here, and you can actually cancel this out. So nobody knows that you're looking at the answer and work towards the answer, right? So there you go. That's your first part. Okay, second part, part B, we're supposed to sketch the graph, right? The graph of y equals to modulus sine x. Okay, now we know maybe I would draw a basic sine graph for you. A basic sine graph looks like this. It goes up, down, down, up, maximum 1, minimum -1. So this is from 0 to 2 pi. Now, before you modulus, this is what we have. The moment you modulus, what happened is that the entire graph that falls below the x-axis is now reflected upwards. So that means that we have to reflect this. Your graph will be like this. It will be like a double top. So let's just map it out, 0. Break it up into 4 segments. This is 2 pi. This is x. And we're drawing from 0 to 2 pi, right? This is pi over 2, 3 pi over 2. I think I'll just put maximum 1 here. So put a point to make sure you have a good balance in your graph, right? So it goes up. Okay, one more thing. You should use a darker pencil, like 2B pencil. It will help you to cover, or should I say, avoid ugly looking graph, right? Cover your ugliness. Okay, my graph is not very nice because this point probably should be a bit closer to the right. So, okay. Second point goes up and down. Okay. Avoid drawing a graph that's a bit too, I know some students draw the graph, right? Let me show you. Okay, this is still a bit ugly. I can do better than this. Okay, some people draw a graph with too fat. Well, this is not the sine graph. Or some people draw a graph too triangular-like. Now it's not. It's supposed to have a nice curve like this. All right. It's somewhat similar to quadratic parabolic shape. All right. I got my graph done. Okay. Next, the graph of modulus sine x done. Next, what I need to do is to find the range of values k. They say that sketch a straight line that satisfies this equation, where k is a constant, that will produce 4 number of solutions. Okay, in order to have 4 number of solutions, right? Now, first of all, we know modulus sine x. This is Roman 1, Roman 2. Modulus sine x is now k. So this consists of 2 graphs. The first graph is y equals to modulus sine x. The second graph is y equals k. So y equals to k is a horizontal line. Now, my question is, where do I draw my horizontal line? Well, if you draw it here, y equals k, you have no solution. If you draw it here, you have 4 solutions. If you draw it here, you have 1, 2, 3 solution. If you draw it here, you have 2 solution. And if you draw it here, you have no solution. So now we just have to identify where I should draw my graph in order to have 4 solutions. So I'm just going to use a blue pen instead of black. So I draw here. Yeah, your y equals k should be somewhere between 0 and 1, right? At 0, you have 3 solutions. At 1, you have 2 solutions, right? But this one, maybe I write here, y equals to 1. This one, it's very hard to draw this dotted line here. This is y equals to 0. But I don't want 2 solutions, I don't want 3, I want 4. Anything in between these two are 4 solutions, right? So in order to have 4 solutions, your k value must be anything between 0 and 1. Okay? Okay, moving on to this is from 4 chapter 8 vector. All right, let's get started. Now, diagram shows a quadrilateral AEFG and triangle ABD. All right, and such that BD and AG intersect point C. Given that AB equals 4x, I'm going to label here this is 4x. CB is negative half y. Now, CB means I'm going up is negative half y. I think we can actually make it positive by switching the sign. So if CB is negative 4y, BC negative half y, BC is positive half y. And GF is now 3 over 2y. So you can see they're parallel. Yeah, 3 over 2y. Yeah, both are in terms of y. And EF is 3x. So these two sides are parallel as well. And the ratio BCCD is 2 to 3. That means if I do BCCD 2 over 3, CD, if you crisscross that, is 3 over 2 BC, right? Since I know BC is half y, CD will be 3/4 y. So I'm going to label here 3/4 y. Yeah. So this is easier for me to calculate the rest. Okay. So just map everything on the diagram. Now let's find vector AC. Okay. If I want to find AC, I can go from A to B, B to C, right? Okay. Let me write down here. Yeah. AC. This is part A. AC is A to B, which is 4x, right? You can see from here, 4x. BC, half y. So we can actually write this directly, half x, 4x plus half y. Okay, second one, how do you go from A to D? Well, A to D, I can go from A to B, B to D, right? So A, or you can say A to C, C to D, right? Since I already know that my AC is this, I just have to plus my CD, just go a bit more. CD is 3 over 4y, right? Add 3 over 4y. So this will give us 3 over 4 plus 1 over 2 is 5 over 4. So answer 4x plus 5 over 4y. Yep. I got my first part done. Okay, next, part B. Your given AG is now lambda times of AC. Yeah, AG is lambda times of AC, and AE is mu times of AD. You're supposed to express vector AF. Yeah, so that means I want to go from A to F, but first one in terms of lambda. Okay, in terms of lambda, right? We know we have to use this. Okay, lambda, I must use AG equals lambda AC. AG is lambda times of AC. So we already know AC. This is longer, lambda times, okay? And the second one is your AE. AE is mu times of AD, right? So both are going to AF. We are finding AF. So I think the first part, maybe I would write A to F. is A to G plus G to F. Okay, you're finding two versions of AF, one in terms of lambda. If it's in terms of lambda, I must use this one, right? My AG is lambda AC. My GF is 3/2y. Yeah, from my diagram, I can see that GF is 3/2y. Now, my AC already have it here. First part, 4x plus half y. Yeah, we write here 4x plus half y. Then you add 3/2y at the back. So let's multiply the lambda inside. 4 lambda x plus half lambda y. Then you add with 3/2y. So when you add this up, you will get 4 lambda x plus 1/2 lambda plus 3/2 bracket y. So there you go. You got AF in terms of lambda x and y. Okay, for AE, for the second AF, I must use this. AE is now mu AD. Yeah, so that means I'm going to use this part here. I'm going to go from A to F using AE. So I go A to E, E to F. Well, A to E is mu AD, whereas E to F is 3x. Now, your mu AD, your AD, we already have it here. 4x plus 5/4y. 4x plus 5/4y. And then you add with 3x. So when you expand this, you get 4 mu x plus 5/4 mu y. Then you plus with 3x. Okay. Now we can actually put them together. This will be 4 mu plus 3. I factorize my x. Can you see? 4 mu x and 3x. I just take out the x. And then 5/4 mu y. So I got two versions of AF, one in terms of lambda xy, another one in terms of mu xy. Okay, then hence find mu and lambda. So basically what we need to do is to compare these two equations, the two versions of AF that we have, and then we compare the coefficient of x first. Okay, now the number in front of x, or the coefficient of x, as you can see, is 4 lambda and 4 mu plus 3. So when you compare x, we say 4 lambda equals 4 mu plus 3. Now I don't know what to do with this. I'm going to leave it out. Okay, here I can call it equation 1. So I call it equation 3, right? And then I compare y. Now the number in front of your y is now this and this. So basically, I just have to write down half lambda plus 3/2 is 5/4 mu. Now I don't like the fraction. Maybe I just times with 2. All right. I will get lambda plus 3 equals 5/2 mu. Maybe we make lambda as a subject. 5/2 mu minus 3. Equation number 4. All right. I'm kind of out of space. So I need to sub equation number 4 inside equation number 3. All right. So what I have here is 4. 5/2 mu minus 3 equals 4 mu plus 3. So I got everything in terms of mu. So when you times in, this 4 and 2 can cancel, left with 2. 2 times 5 is 10 mu. 4 times negative 3 is negative 12. This is 4 mu plus 3. 10 minus 4 will give us 6. 12 I bring over. 12 plus 3 will give us 15. My mu is 5. 15 divided by 6, 5/2. Okay. Now, when you sub inside equation 4, you will get your lambda. Your mu is 5/2 minus 3. Another nice number. This is 5 times 5 is 25. 25/4 minus 3 is, you can use a calculator, 25/4 minus 3. You get 13, 13/4. Okay. Very long question. Okay, let's move on to question number 6. This is differentiation form 5, chapter 2. So given the first derivative of this function is this, find the value of h. So basically we have to use the product rule, right? Remember, if your y equals to uv, when you differentiate dy dx is, you copy u, differentiate v, differentiate u, copy v. You can say uv prime plus u prime v, or vu prime. Okay, so my u is 3x, right? If you differentiate u prime, is 3. My v is x squared plus 5 power 4. Well, my v prime will be, bring the power down, copy the bracket. I'm using composite function. I bring the power down, copy the bracket, reduce the power by 1, and differentiate inside. Differentiate x squared, you should get 2x. I hope you remember this. This is the composite function formula. If y equals to kfx to the power of n, when you differentiate this, you bring the power n in front, you copy your fx, you reduce the power by 1, and you differentiate whatever inside the bracket. In this case, your bracket is x squared plus 5. When you differentiate x squared, you get 2x. You differentiate 5, you get 0. Okay, so we can put them together as 8x with the x squared plus 5 power 3. Okay, so let's differentiate this. Now, it's okay to write dy dx straight away. Yes? When you differentiate this, we copy your u. I'm using the formula here. Copy your u, 3x. Differentiate your v, 8x, with the x squared plus 5 power 3. Then you differentiate your u, you get 3. Copy your v. Your v is x squared plus 5 power 4. Now, personally, I like to use this. I like to maintain the u and u prime in front, whereas the v prime and v at the back, because it is already arranged in a nice order, as in the bracket, the power 3, power 4, they're all at the back. So it's easier for us to factorize. Now, when it comes to factorization like this, if you find it's a bit hard to factorize directly, you can use what we call the algorithm method. That is, I have 3x and 8x, x squared plus 5 power 3, and 3 x squared plus 5 power 4. So we first take out maybe the bracket, x squared plus 3, x squared plus 5, yeah? So I'm going to take out x squared plus 5 here, power 3. So I'm left with 3x and 8x. Now, whether you want to times the 3 with 8 or not, it doesn't matter. So I'm left with 3 and x squared plus 5 power 1. Remember, if you have a power 3 and a power 4, we always take out the smaller power being power 3, power 4, take out power 3, left with power 1. Now, what else can I take out? I can also take out 3. I'm left with 8x times x. You want, you can write x squared here, and I'm left with another x squared plus 5. So these two here, we can leave it outside, x squared plus 5 with the power 3. Whatever I have left, I'll just leave it in the bracket. Okay, so with that, I can just add them up. This will be 3 with the x squared plus 5 power 3, and then 9x squared plus 5. Okay, what are we supposed to find? Actually, we're supposed to find the value of h. So you can see, actually, this is the question in a way already guided you. They already say that the derivative is this. There's a 3 outside and x squared plus 5 power 3 outside. So that makes it a lot easier. You know what common factor to take out, right? And we just have to identify what's your h. In this case, your h is 9. All right. Okay, this is the first part. Let's move on to the second part. Okay, so the second part involving what we call small change and approximation. Okay, so here we have a diagram that shows an inverted cone with a base diameter of 12 cm and a height of 18. So given the height of the water in the cone is h and the radius of water surface is r. So you're supposed to calculate. They say the water leaks out from the tip of the hole, the small hole or the tip of the cone. Calculate the small change in the height when the volume decreases from 8 pi to 7.5 pi. Now, before we do even all this calculation, we need to know what is the formula that relates the volume and the height, right? Because what we are interested now is your change in your height. You are finding delta h. So I need to know what is the relationship between v and h. Now, yes, volume is already given as 1/3 pi r squared. h. Now, the problem is this is v in terms of r and h. You have two variables. So now we're going to reduce it to one variable, v in terms of h, or either v in terms of h or v in terms of r. But since you're finding h, we need to change all the r into h. So the question is, what is the relationship between r and h? Well, in this case, we have to use similar triangle. So if you draw a dotted line here, you can see that you have two triangles to compare. The small triangle has a radius of r here, the base here, the length here is r, height is h. The big triangle, if I take 12, I halve it, is 6, 6, and 18. So basically, you're comparing this ratio r, h, and 6, 18. Yeah, and it's like an enlargement. One is an enlargement, the other we call it a similar triangle. So your r over h is always the same as 6 over 18. Yeah, we just enlarge it if you like. Multiply over your r is 1 over 3h. So I need to get rid of r. We can do that by substituting equation 2 inside equation 1. So the moment you sub in, your r is now 1 over 3h. You square it, you multiply by h. So let's expand this out. 1 over 3 squared, let me write slower, is 1 over 9. There's a h squared, you times with one more h. This will give us 1 over 27 pi h cubed. So here I got v in terms of h. Okay, now remember, we already know our volume. Yeah, the volume decreases. So I know my delta v. Okay, so the end result will be delta v, delta v over delta h is approximately the same as dv dh. Given that if your h is small, this is true. So I know I have to find dv dh. Okay, maybe I find dv dh first. dv dh, you can do that by differentiating this. Bring the 3 down. 3 divided by 27 is 1 over 9. It's actually 3 over 27. I bring it down. Copy your pi. Pi is a constant, not involved. Copy h. Reduce the power by 1. And you're finding this rate when your volume decreases from 8 pi to 7.55. Now, here's the problem. This question is really long. I don't know what is my h value that I have to sub in, right? I need to find out what is the h value that I can sub in here. Now, you're given initially your h is 8 pi. The volume is 8 pi. So you go back to this formula here. Initially, your volume is 8 pi. We find out what is your height. So take the pi and pi cancel. 8 times 27 is 216. Again, you can't do this mentally. It's okay. Calculator, 216. Okay. So when you cube root, this should be 6. Okay. Cube root of 216 is just 6. Okay. Now that I know h is 6, we can sub inside here. dv dh is 1 over 9 pi 6 squared. Okay, 6 squared is 36. 36 divided by 9 is 4. So this will be 4 pi. Okay, I still need to do one more thing. Now, in order to use this formula, I need delta v. So what is your delta v? My delta v, in this case, they say it reduces from 8 to 7.5 pi. So we take the final 7.5 minus the initial 8 pi. The reduction is negative 0.5 pi. So with that, I know my delta v, I know my dvdh, I just had to find my delta h. So let's take negative 0.5 pi divide delta h equals dvdh will be 4 pi. So bring this delta h up. Maybe I show you one more step. Bring the 4 pi down. Yeah, I'm switching this up, bringing the 4 pi down. So it's basically 0.5 divided by 4, 0.125 or 1 over 8. Right? It's negative. Answer is negative 0.125. Okay, the pi cancel each other out, so no more pi. All right. Okay, let's move on to the next question. This is Form 4, Chapter 5, Progression. Okay, so the first part is, this is a geometric progression such that the sum to infinity of this geometric progression is 6, and the sum of the first two terms is 5, 1 over 3. So find the possible common ratio. Okay, now we know formula for sum to infinity is given by a divided by 1 minus r. Okay, so in this case, your and sum of the first two term, sum of the first n term, we can use this a 1 minus r power n 1 minus r. Yeah. Now, normally we use this for the case where r is less than 1. Since you have sum to infinity, we know your r should be less than 1, right? In fact, your r should be between -1 and 1. Whenever you have sum to infinity, your r must be between -1 and 1. Okay, so first of all, my sum to infinity is 5, 1 over 3. So I'm going to write a divided by 1 minus r. Okay, over here equals to 5, 1 over 3. All right, now we can call this equation 1. Now, if the 5, 1, even 5, 1 over 3, right, you can actually change to 16 over 3. Yeah, so let me write 16 over 3, equation 1. And your sum of the first two term, sorry, sum to infinity is 6. Sum of the first two term is 5, 1 over 3. So we use a 1 minus rn, 1 minus r, your r has power 2 now, divide 1 minus r. The result, 16 over 3. Okay, for me, right, I can see that this itself is your sum to infinity. Can you see this? A divided by 1 minus r. Now, if you're unsure, you're not sure, you can actually divide them, right? I was thinking to substitute directly. It's easier to actually substitute directly. But if you want, you can actually divide them, as in we take equation 2, divide equation 1. So what you have here, a 1 minus r square, 1 minus r, divide by a 1 minus r. Okay, and this will be 16 over 3 divided by 9. Now notice we can actually cancel this two. I'm going to cancel a and a, 1 minus r, 1 minus r. Right. So sorry, this is not 9, this is 6. Okay, so let's just take this and divide them. Use your calculator. 16 over 3, you divide by 6. So I got 8 over 9. All right, so you're left with 1 minus r squared. Let me continue here. 1 minus r squared is 8 over 9. Your r squared is 1 minus 8 over 9. I bring this over. R squared is 1 minus 8 over 9, which is 1 over 9. When we square it, there's always a plus minus. So the question asks for possible common ratio. In this case, your r can be plus minus 1 over 3. You can write separately, negative 1 over 3, comma 1 over 3 also can. All right, so that is the first part. Let's move on to part B. Okay, during the outbreak of flu virus in town A, approximately the rate of infection increases daily by 15% from the previous day. So on the 1st of July, number of cases is 30. So this one is still a geometric progression. First day, 30 cases. Now, when we say increase by 15%, so you need to understand percentage is always geometric progression because percentage by itself is a ratio, right? So the first day is 100%. Second day increase by 15%. So you have 115% now. So by taking 115 divided by 100, your rate of increase or your common ratio in this case is 1.15. Okay, so now we want to find an estimate for the total cases in the month of July. Now we know July there are 31 days. So the first day, your T1 is the 1st of July. On the last day is T31. Since you're finding the total cases, we are finding S31. Again, we can use the formula for Sn, A. By the way, for in the event that your R is more than 1, normally we use this. But again, if you use the other formula, 1 minus Rn, 1 minus r with the a outside, it's the same. You will get the same result. It's just that you have a negative value, divide by negative value. Eventually, you still get a positive value. So my r is now 1.15 power 31 minus 1, divide by 1.15 minus 1. Okay, so we're going to use a calculator. Here, I'm just going to write 30 over. This one I put 1.15 minus 1. You can actually just write 0. 15, huh? And your numerator here, we'll put a bracket, 1.15 power 31 minus 1. Okay, my answer is 1502. If you round off right, it should be 029. 15029. Okay, 15029. Total number of cases is 15,029 cases. All right, now starting 1st of August, preventive measure has been taken by the local authority to deal with the outbreak. Given that the number of new cases of 1st and 31st August is now this and this, right? Determine the estimated infection rate from 1st to 31st August. Do you think preventive measure should be taken gives positive effect? Give your justification. So that means that what we want to know is that we want to know whether the rate has decreases. Before this, the rate of increase is 15%, right? Daily in the month of July. So we want to know if you have done a lot of preventive measures like social distancing, vaccine, and things like that we all learned before, right? Okay. Will it actually reduce? Okay. So to find whether it has reduced or not, so what we need to do is to find the value of R. Okay, so let's start. Now, my first term, my R, is an unknown, but I know my first term now. In August, I got 2284. Okay, and on the last day, my T31, August, there are 31 days, 45464. So I know my A, I know my N, my Tn. I want to find my R. So we know A, R, N minus 1. Remember, formula for Tn is A, R, N minus 1. So your R is 30, your N is 31. 31 minus 1, we can write this as 30. The result is now 45464. So let's find out what is R power 30. Take 45464, divide 2284. What I have here is a very big number. Maybe I leave it in fractions better. 11366 over 571. 11366 over 571. 11366 over 571. Now, when you bring this over, you have to power 1 over 30. Now, this is the annoying part. 1 over 30. You know that if this is x squared equals y, you bring over y's power 1 over 2. If this x power n is y, x is y power 1 over n. So when I bring the power over, it's now going to give us 1 over 30, right? Okay, so let's just use a calculator. I've already got this value. I just power 1 over 30. Now, my R in this case is 1.10. Well, you can write 1048, the whole thing if you want. Yeah, 1.1048. So that means, what is the rate? The rate, if you want to find the rate, right? We just take 1.1048, you minus 1, right? And then you multiply by 100. So it's basically 10.48%. So what can we say about it? That means, is the preventive measure taken effective? Yes, answer is yes. Why? Because the rate of infection, right, has reduced or decreased, right? Before this, it was 15%, right? Now it has reduced to 10.48%. So it's working, right? Okay, let's move on to the next one. This is section B, question 8. This is form 5, chapter 5, probability distribution. The first part is a binomial distribution. Okay, so in a survey conducted in a school, it's found that 1 out of 3 students is selected to attend an intervention class. So if n student is selected randomly selected, the percentage is exactly a student not selected is equal 10 times percentage of all students selected, calculated with n. Okay, so we know it's a binomial, right? So a binomial, we need to know the probability that the student is selected for the intervention class is 1 out of 3. Okay, now we don't know what's your n. If n students are selected, maybe n is 5, 10, 15. Now we know that the percentage, now remember percentage probability will be the same. Probability you multiply by 100, it gives us a percentage. But percentage of student that exactly one student not selected. Oh, here's the problem. If you have selected, okay, maybe we talk about X is number of students selected. Okay, so maybe I would say selected, not selected. Okay, if selected is 0, not selected will be N. Selected is 1, not selected is N minus 1. Selected is 2, not selected is N minus 2. So that your total is always N. And so on. If you select N student, the number of students not selected will be 0. Okay, so here's the thing. They say exactly one student not selected. Okay, one student not selected means here. How many students selected? N minus 1. To try to confuse the student, right? So a lot of people would tend to write X equals to 1. No? So if you say one student not selected, that means N minus 1 student selected. This is 10 times, right? The percentage of all students selected. All students selected means X equals to N. Okay, so remember the formula for binomial Px equals to R is NCR, P power R, Q power N minus R. And the probability of success and failure, P is success, Q is failure, is 1. So Q is always 1 minus P. We know that. So in this case, my Q will be 2 over 3. So I'm going to use the formula, sub inside. This will be NC N minus 1, right? My R is N minus 1. Your probability of success is 1 over 3 power N minus 1. Your probability of failure, Q, is 2 over 3 power 1, right? Remember, these two add together must give us N. So N minus 1 plus 1 will give us N. So this is 10 times NCN P power N Q power 0. Okay, what we need is to simplify this further. Now, we know that NC0 is 1. NC1 is the same as N. Now, I don't know whether you know about this. The NCR thing, we can actually use a Pascal triangle, right? The 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. That is, if I have, this is your 0C0, this is your 1C0, 1C1, 2C0, 2C1, 2C2, 3C0, 3C1, 3C2, 3C3. This will be 4C0, 4C1, 4C2, 4C3, and 4C4. Now notice this NCR notation, they are actually symmetrical. That is, 4C0 is the same as 4C4. 4C1 is the same as 4C3. Now it works for everything, like NC0 is the same as NCN, NC1 is the same as NCN minus 1, right? In fact, NCR is the same as NCN minus R. Okay, so now I would like to do this straight away. I know NCN minus 1 is the same as NC1. And NC1, NC0 is 1, NC1 is N. Out of N item, I choose 1. I choose 1. So how many options do I have? N. Yeah, so this is just N. All right, this is 1 over 3 power N. Maybe I write here as divide 1 over 3 power 1. This is 2 over 3 power 1. And this is 10. NCN is 1. And I have 1 over 3 power N. Now, why do I break this up? Because I can see that I can cancel these two. It'll make my life a lot easier, right? As for this 1 over 3, actually you can invert it. You can actually cancel this, right? 1 over 3 and 3 and cancel. So now you're left with 2n. And 2n is now 10, and your n is just 5. All right? Let's move on to part B. So part A is a binomial. Part B is a normal. Okay? So for normal distribution, okay, So here we have a cross-country competition with a participation of 100 runners was held by MRSM. So time taken is normally distributed mean of 45, variance of 2 to 5. Now be careful, this is variance. If you want to find standard deviation from variance, we're going to square root it, you get 15. If your variance is 2 to 5, right, your standard deviation is 15. Okay, now here, runner who managed to complete the race within 40 minutes were awarded medal. So find the probability of choosing a runner who did not get a medal. Okay, so you will get a medal if you complete within 40 minutes. So if you don't complete, or should I say, you took longer than 40 minutes, then you don't get a medal, right? So what we can do here is to find the probability of x more than 40. So here, I think we can just use standardization, 40 minus your mean, which is 45 minutes. Standard deviation is 15. So let's take 45. 40 minus 45 is 5. 5 over 15 is 1 over 3. Now, here's the thing, the number is a bit ugly. 1 over 3 is 0.333, right? So this is z greater than 0.333. So the thing is, we have to use a mathematical table. A moment, let me just open my mathematical table. Notice there's a negative here. 40 minus 45 over 15, there's a negative here. So we are finding for the probability of z more than negative 0.333 here. Now, why do I use 3 decimal point? It's because your mathematical table can read up to 3 decimal point. So here, 0.3 is over here. I read, second 3 is over here. So this, the third 3 is, you have to subtract. So that means you have to subtract 11 from the last 2 digits here. So let's take 0.3707. You minus 11. This should be 0.3696. Okay. All right. So this I have to do 0.3696. 3696 this area here, because I need to do 1 minus z more than 0.333, which is 0.3696. This will give us 0.9304. Now, alternately, you can actually use this calculator. If you have this calculator, you can press mode. You go to 3 for stats. You go to AC. Press shift, 1 for stats, 5 for distribution. Press 3 for R. Remember, this the upper tail here is your R. You press 3, 0.333. There you go. 3696. As I do 1 minus answer, I'll get, sorry, I wrote wrongly. This is 0.6. Yeah, 6304. Yeah, 0.6304. Okay, another calculator you can use, this one is even better, because this calculator we can actually count even right from here. Like, for example, you can use this to double check your answer. You go to number 7 for distribution. All right, you go to number 2 for normal distribution. So if you just want to read from here, right, z more than 0.33, then your lower is 0.333, your upper is infinity. Infinity, we just put 999. Yeah, it's good enough. Your standard deviation is still 1. Your mean is still 1. Your mean is still 1. So there you go, 3696. Now you can also choose to change your lower limit to 40. Yeah, this is directly, well, and this is without working whatsoever, but you can use it to double check your answer. Your upper limit is still 999, still goes to infinity. Your mean standard deviation is 15. Your mu is just 45. Now notice you'll be getting the same answer directly. Okay, but sometimes the answer is slightly different, because when we round this off, right, 0.333, it is not a very accurate answer. Like, for example, if you use this calculator, you type in 3 for R, instead of using 0.33, use 1 over 3. You notice your answer a bit different. Is 3694, not 3696. That's why sometimes there's a difference in the answer, right? Because we are using the exact value versus rounded off value is 0.333. But for, to get the same answer, most of the time the marking scheme will just follow the mathematical table. So we'll just use 3 decimal point because the mathematical table can read up to 3 decimal places. All right. Second part. The organizer rewarded cash money to the first 10 runner that completes the run. If Kamal finished the race in 25 minutes, did he qualify? Not was he qualified? Did he qualify for the reward? Okay, so here's the thing. There are 2 ways to look at it. Some people may calculate the probability of, because they say first 10 runner, you have 100 runner. Yeah, first 10 runner means what? You can only get the chances of you getting the reward if you must complete in a time less than, let's say, t minutes. All right, so this is 10 first 10 over 100. That means it's 0.1%, right? 0.1%. So 0.1, probably 0.1 or 10% chance that he will qualify. But we want to compare his time here with the t value that he will get. Okay, so what we can do is we can standardize it. This will be t minus mean, which is 45. Standard deviation is 15. This is 0.1. Okay, now you can see here, this is actually, if I do a sketch, right, it's actually on the left-hand side. This is t minus 45 over 15. There's a 10% chance. Okay, I need to find what is the z value when my probability is 0.1. Okay, there are 2 ways to do it. Number 1, use your calculator, use your mathematical table. 0.1. Okay, let's find 0.1. Where is 0.1? Okay, slowly, you're going to find inside here, because this inside here is a probability. Find a value that's slightly more than 0.1. In this case, it's 1.28. Now, I need to subtract 3. Okay, to subtract 3, you either use 2 or use 4. In this case, both are okay. Because you cannot subtract. If you subtract 2, it's 0.1001. If you subtract 4, it's 0.90999, right? So I think maybe I just use the first one. So if you read from here, you get 1.281. Remember, it has to be subtracted. When you subtract from the bottom, you have to add from the top. So it's 1.281. Let's go back to this. So I know that when I read z more than 1.281, I get 0.1. But this is z more than. More than means this side. Okay? 1.281. But this is on the left. So we can flip it over. So we know that if I were to flip, now you don't have to write this if you don't want to. Negative 1.281 is also 0.1, right? When you flip this to the left, negative 1.281, 281, not 282, this is also 0.1. Okay, so we know that your t minus 45 over 15 must be the same as negative 1.281. Now, you can double check using this calculator. If you have this calculator, only the black and white and the class widths can do this. You press mode, you go to 7, you go to inverse normal 3. Then you key in your area as 0.1. Okay, now you put in your sigma is 1, mu is 0, because it's a standard normal distribution. You press equals, it's negative 1.2815. Now, you can write 282. Yeah, it's actually between 1 and 2, 282, 281, both also can. Yeah, it doesn't affect your final answer because a lot of decimal point here. So this is another way to calculate. If you don't want to use a mathematical table, then you use this calculator. All right, now we just use calculator to count. I'm going to take negative 1.281. I times with 15, I plus with 45, and what I'll get here is 25.79. Yeah, 25.79. Okay, so that means that if you complete the run in less than 25.79 minutes, you will be able to qualify for top 10 and you will get a cash money. So come out finish in 25 minutes, right? Okay, this one we can actually round off if you want. You can round off to 26. You will round off to 26 minutes, right? So he finished in, yeah, less than this, right? So you can say Kamal finish, or should I say this one is Kamal finishes in 25 minutes, which is less than 26, or you can put 25.79. All right, therefore, answer is yes, he qualified. He qualified for the reward. Okay. Okay, moving on to the next question. This is Form 4, Chapter 6, Linear Law. So here we have to use a graph paper to plot the line of best fit. Okay, so first of all, we are given a table that shows two variables T and B obtained from experiment to investigate the relationship between temperature and gas pressure P. So the relationship is given by this formula, P squared equals Q R power T. Okay, so first, based on the table, yeah, plot log 10P against T. Log 10P against T. So I think I would have to recalculate your log 10P. Let me do it here. Your T doesn't change, so I don't have to redraw the table values for log 10P for T. So, okay, let's start. We start off by taking logarithm of this value, 2.05. So the first answer is 0.32. All right, 0. So it look like 0.331. 31 to 31 will do, 0.31. Second one, let's take logarithm of 3.55. You can just change this, 3.55. I got 0.55. Okay, so next one, take logarithm of, you can just type log of 5.62. Okay, this will be 0.75. Okay, next, let's take logarithm of 6.18, 0.79. Okay, let's take logarithm of 7.96. I will get 2.9. This is 2.990. And lastly, logarithm of 10.71. I got 1.03. Yeah, 2 decimal point will do. Okay, so now we're going to plot log base 10P against T. Okay, your axis, they say that use 2 cm to 5 unit on the horizontal, and then 2 cm to 0.1 on the vertical. Now, here you notice that your smallest value is not 0 for t-axis, the horizontal axis is -5. So you will need a -5 on the left-hand side here. So let me move this up a little bit. Yeah, this is -5 here. All right. Maybe I put 0 here. 5, 10, 15, 20, 25. Largest is 25. Okay. Now, next, for your y value, the scale is 0.1. So 0 is here. So I'm going to put 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Largest is 1.03, 0.7, 0.8, 0.9, 1.0. Now, the highest will be 1.05. And this will be your log P, LGP. Okay, I need to draw line here. Let me just add in the line. Okay, so the first line is, let's draw a horizontal line from here to here, right? And draw a vertical line from here all the way up. I need to adjust this. This is your horizontal and vertical. Just adjust like this. Okay. All right. So there you go. Now let's plot the point one by one. The first point is -5 and 0.31, which is over here. Second point is 5 and 0.55, 5 and 0.55. Next point is 10 and 0.75. 75 is in between. Next point will be 15 and 0.79, 0.79, okay, followed by 20 and 2.9. 2.9. Wait, I think this is not 2.9. I think I typed this wrongly. This is log 7.96. 0.9, not 2.9, 0.9, I wrote wrongly. 0.90. Okay, so 0.9 will be over here. And the next one is 1.03, 25, 1.03. Now, 1.01 is two boxes. Your 1.02 is here, 1.03 is slightly higher here. Now, sometimes you may have to read the whole question because the question mentioned, you read the whole thing and they say, it is found that one of the values of P has been wrongly recorded. From the graph, determine the correct value of P. So we know 1 point is out. Now, when you look at this, right, most likely is the third point. Yeah, you can see here the first point right up to the last point, most of them are on the line of best fit. Yeah, okay, most of them are on the line of best fit except for this point. Okay, and also I think I may have to do some adjustment because this point has to be a bit lower. You can see that one should be above, slightly above, one should be slightly below. See that? Right? So yeah, almost all the points are on the line of best fit, except for the last two. Okay, the last two, this is slightly above, this is slightly below. Okay, so and this point definitely is out. Yeah, this would be a wrong point that's wrongly plotted. Okay, I think this is okay, right? 1.0. Okay, so now when you plot the graph, yeah, the main thing from linear law is you need to find two things. So you find gradient and the y-intercept. Okay, before we even do that, we need to find out what is the value of P that's wrongly recorded. Okay, I can see from here, the wrongly recorded value. Okay, so maybe I say wrong value of P is here. It happens when your T value is 10. So the wrong value is 5.62. Now, how do you find the correct value? Now, based on the line of best fit that I've drawn here, right? When your T is 10, I got 0. It looks like 67. Yeah, 67. Huh? With off here, yeah, 0.67. Okay. Maybe 68. Yeah, 67 to 68. Okay, actually closer to 67, I think. Okay, maybe I zoom in a bit, hard to see, right? Okay, if you zoom in a bit, I can see clearer. Yeah, it looks like 0.67. Yeah, between 6.7. Now it's okay to even use 6.8. It's 6.7 here. See this? Yeah, when I zoom in, I can see clearer. Yep, it's correct. 0.67. Okay. All right. Let's zoom out. And now what we want to do is want to find the correct value. The wrong value of P is this. The correct value, remember, this is log base 10 P. So your log base 10 P is 0.67. So we can say from the graph, your log base 10 P is 0.67. To find P value, right, we need to use a calculator, shift log, or we call it anti-log, 0.67. And my answer is 4.68. Yeah, so my correct value is 4.68. Now, remember, you may get a slightly different answer. Some of you may get 0.68 or 0.675. You can read up to half of the smallest box, right? So if your graph is 0.675, yeah, I think it's okay. All right, or even 0.68. Okay, so now next, two things we need to find from the graph. We need to find the gradient and the y-intercept. Okay, to be able to find the value of Q and R from this equation here, because we at the end of the day will find Q and R from this equation, you need to find the gradient and y-intercept from the graph. Now I can see from my graph, right, my y-intercept, let's take 2 points. Okay, let me zoom in a bit, okay, because you might get a slightly different answer. It looks like 0.43. Look at this, 0.43, my y-intercept, okay, 43, yeah? And I need another point. So this coordinate, we can say is 0, 0.43. And I like to use 5 boxes horizontal because any number divided by 5 is a nice number. By the way, this is just your t value. So I count 5 boxes to the right, 1, 2, 3, 4, 5. Now I'm going to take this point over here. This is 1 point. It looks like 1.02. This point here, yeah, it looks like 25 and 1.02. Okay, so let's take this 2 coordinate to find your gradient. Okay, so I'm going to move down to the next page. Let me find the gradient here. Yeah, okay, my gradient is 1.02 minus 0.43, 25 minus 0. I'll check again the coordinate, 25 and 1.02, 0 and 0.43. So I'm taking y2 minus y1 over x2 minus x1. Okay, use your calculator. All right, take 1.02 minus 0.43, divide 25 minus 0 is just 25. My gradient is 0.0236. Yeah, 0.0236. You might get a slightly different answer, but that's okay. Yeah, 236. Some of you may get 0.23240. Okay. All right. So that's my gradient, and my y-intercept is 0.43. Okay. Let's go back to the equation here. Your equation is p squared equals to qr to the power d. Okay. So let me work it out here. My equation, q squared equals to p squared. P squared equals to qr to the power of d. And we're supposed to find the value of q and r. Okay, my r is a small r. Let me check again. The r is a small r, yeah. So let's change this. Okay, so let's take logarithm. I know how to use logarithm. You can write LG. LG stands for log base 10. It's a short form for log base 10. We take logarithm on both sides of the equation. All right. Then we bring the power down here to LGP. This is LGQ plus LGR. The power T, again, you can transfer it down. Now, the next thing is this T is your Y x-axis. You can see your x-axis. All right. So whatever number in front will be your gradient. This log B here, it has a 2 in front. So we want to make this as your big Y. So we're going to divide by 2. As I divide by 2, this T, right? Okay, I do a bit slower. Let me write step by step. I put in front, then I put the half LGQ. Now, when you rearrange it, your LGR, this will be your gradient. This is your T, your big X. This is your Y-intercept. So you want to compare. This is your big Y. This is your gradient. This is your X. And this is your C. Now you want to compare your gradient from your equation, which is half LGR, with the gradient from your graph that you've calculated, 0.0236. So your LGR is now 2 times of this times 2, 0.0472, 0.0472. To find R, I just anti-log. Anti-log means shift log answer equals 1.115. Yeah, my R is 1.115. Now remember, because if your gradient is slightly different, like 0.024 or 0.023 or something like that, slight difference, your answer for R will be different as well. Yeah, but usually a small difference is okay, right? Now, how about your y-intercept? My y-intercept is half LGQ, and it is the same from the graph 0.43. So I just have to multiply by 2. This is 0.86. All right. From here, again, I use my calculator, shift log, anti-log, 0.86. And my Q is 7.244. Yeah, a slight difference in answer. If you use if your y-intercept 0.42 or slight difference, you might get a slightly different answer for your Q as well, 7.244. Okay. All right, so that's how you find the value Q and R from the equation. Moving on to the next question. Question number 10. This is coordinate geometry, Form 4, Chapter 7. Okay. So, okay, number one, you are given a diagram here that shows a quadrilateral such that A, D, M, and point M. M is the midpoint of AC. B lies on the perpendicular bisector of AC. So you're supposed to find the equation of perpendicular bisector AC. Okay. So number one, if this is a perpendicular bisector, they say M is a midpoint and B lies on the perpendicular bisector. So we know a perpendicular bisector must divide this into 2 equal half. All right. And in this case, this line passes through point B. So to find the equation of straight line AC, number one, equation of perpendicular bisector AC, number one, you need to find the gradient of AC. Now we can use y2 minus y1, find the gradient, y2, which is 9, minus y1. Now your AC is actually the same as the gradient of AM. Now maybe I should write AM because C, the coordinate is not given, but we know AC and AM, they are actually the same. They have the same gradient. So I'm going to write AM here. My gradient AM is 9 minus 3 divide minus 9 minus 8. So, sorry, minus 9 minus minus 8. Right. I think this line, this is 5 because I couldn't see clearly. This is -5. Okay. So this is now 6/4 or 3/2 with a negative. Right? So this line is over here. Yep. You see it passes through M. Okay. Second thing, let's find out the gradient of this perpendicular line. Now we know that when two lines are perpendicular, M1 dot M2 must be -1. So your gradient of your second line is now 2/3. Okay, so now that I know gradient of this line is 2/3, and we know it passes through point M. So we can use the equation y minus y1. Remember, to form equation straight line, we use y minus y1, m x minus x1, where m is your gradient, and x1, y1 is a point that it passes through. Now, since it passes through point M, so my y1 will be 3, my gradient is 2/3, my x1 is -5. So minus 5 becomes a plus 5. So let's multiply this up. 3y minus 9 equals 2x plus 10. Bring it over. 3y is 2x plus 19. There you go. Your equation of straight line will be this, 3y equals 2x plus 19. Okay, so that's part A. Part B, I want to find area of quadrilateral ABCD. Okay, I know point A, I know point B, I know point D, I need to find point C. But in fact, point B, I am still short of the value of K. I need to find the value of K. Now, since this perpendicular bisector passes through B, we can sub in -8 and K to find the value of K. So my Y is now K, sub inside here. My X is now -8. So this is -16 plus 19, which gives us 3, and my K is just 1. So your coordinate point B is -8, 1. Okay, now that I know point B, I still need to find point C. And we know that M is the midpoint of AC. So we're going to let C be X, Y. So let's take -9 plus X divided by 2. We know this must equal to -5 because the coordinate point M is -5, 3. The X coordinate is -5. Then we continue with 9 plus your Y divided by 2. The result must equal to +3 because your Y coordinate of point M is just 3. So let's just multiply the 2 over. This is going to give us -10. Bring over X is -1. Multiply this over. 9 plus Y is now 6. Y is just -3. So once you got your X and your Y, we can say that the coordinate of point C is now -1, -3. Okay. The next thing is we are supposed to find the area of quadrilateral. Your quadrilateral ABCD, we start off with half x1, y1. This represents the coordinate point A, the first point here. B is -8 and 1. C, we know now, is -1 and -3. D is 1, 9. Then we repeat the coordinate of the first point, coordinate point A. Now let's multiply this down. Remember, this method, you're going to multiply downwards diagonally. So this is -9. Yep. Plus -9 times 1 is -9. -8 times -3 is +24. -1 times 9 is -9 again. 1 times 9 is +9. Now, then you minus this way up. Now, it's up to you. Some people put a bracket and count one shot, one by one. Some people make times inside. So let's say if I were to put a bracket negative, this way up is 9 times -8 is -72. 1 times -1 is -1. This is -3. This is -81. Okay, you can just use your calculator and count, right? Don't have to, count one by one. So you can just do one shot. -9 plus 24. The -9 plus 9 will cancel each other out. So I can just do this out. All right, then I minus. There's a -72. We can -1 -3 is -4. Then you minus 81. There you go. My answer is 172. Okay, so we take the 172 that we got, we multiply by half. So take this answer times half, or you just divide by 2. Your answer is 86. So your area is 86 square unit. All right, finally, this is now part C. Okay, they say that a circle Z represents the locus of a moving point B that moves such that its distance from point A is always constant. Point D lies on the circle Z. Find the equation of Z. Okay, so one thing you notice that D and A, they lie on the same horizontal line because your y coordinate is 9. Your y coordinate here is also 9. So it's a horizontal line. So when it's a horizontal line, it's actually easier to calculate the length, the radius of the circle. And since A is the center, right? And D is on the circumference. We say that distance from point A is constant. That means A is the center of the circle. And if you take the distance AD, it is actually 9. Since this is 1, 9, so we take 1 minus -9. 1 minus -9. This is going to give us 10. And we can see that your equation of locus is A to P, where P is a moving point, right? Okay, should I say your moving point is P? The result is always 10. So let's just use the formula for distance. The distance from point A is constantly 10 units because your radius is 10. So let's take x minus -9 because your x coordinate point A is -9. You square it plus y minus 9. You square it, the result is 10. Okay, let's expand this. X squared, 18x, 81. This is y squared, 18y, 81. 9 squared is 81. And 10 squared is 100. So let's simplify further. X squared plus y squared plus 18x minus 18y. Now, 81 plus 81 is 162. 162 minus 100 is just 62. There you go. That's your final answer. Your answer is in this form. We call it the equation of a circle. Moving on to the next question. And the next one is Form 5, Chapter 3, Integration. Okay, I think we can zoom in a little bit. Form 5, Chapter 3, Integration. Okay, so diagram shows a curve y equals x squared, right? Y equals to x squared plus 3, and the gradient of tangent to the curve at point P is given as 6. Okay, all right. We are supposed to find the area of the shaded region. Okay, so let's start. If you want to find area of shaded region, the first thing is we know that this region is bounded by, should I say, consists of this curve, right? This area under this graph, and then you subtract the triangle here. Now, the problem is we don't know what is this x coordinate. Now, we don't even know what is the coordinate point P, right? So to find the area of triangle, or even your area integration, we need to know what is your x coordinate point P. And in fact, we need to know the y coordinate point P so that we can find the height of your triangle. Now, but we're given this information, we're given a gradient of tangent at P is 6. So in this case, we have to use differentiation. Yeah, it's not just integration, we have to use differentiation as well from 5 chapter 2. So number 1, we will have to differentiate dy dx. When you differentiate x squared, you should get 2x. When you differentiate 3, you get 0. Now remember, dy dx means gradient of tangent. So the gradient of tangent point P is now 6. So we can replace your dy dx with 6 and find your x coordinate. 6 divided by 2, answer is 3. So your x coordinate point P is just 3. So once you know 3, we can find your y coordinate. We just sub inside your y here. 3 squared plus 3. 3 squared is 9. 9 plus 3 is 12. So your coordinate point P is 3, 12. Okay, if I know this is 3, 12, I know this is 12, I know this is 3. Okay, I still need to find what is the x coordinate of this point here. That means first I need to form the equation of tangent. Then I find the x-intercept of your equation tangent. Now we know the gradient of tangent is 6. So we know point P. So we can use y minus y1. My y1 is 12. My gradient of tangent is 6. My x1 is now 3. Okay. So what I need to do is to simplify this equation. 6x minus 18. Well, we can bring the 12 over. If you want, bring it over or bring this over. So can y equals 6x minus 6. So this represents your equation of tangent at P. Now, at x-axis, your y value is 0. By letting your y value be 0, we can solve for x. Your 6x is 6, x is 1. So this point here is 1. The x coordinate is 1, your y coordinate is 0 actually. Now, once I know this, I can now find the area by taking, first, integrate this curve, y equals x squared plus 3, lower limit 0, upper limit 3, minus area of this triangle. Now this triangle we can see the length from here to here is 2. 1 to 3 is 2. The height is 12. Okay. So let's use integration. 0 to 3. Your function is x squared plus 3 dx. Then you minus half times base times height. So as I integrate this, I get x power 3 over 3. When I integrate 3, I get 3x. Lower limit 0, upper limit 3. This is just 12. Now next, I'm going to sub in 3 inside. 3 cubed is 27. 27 divided by 3 is going to give us 9. Now you can use a calculator if you are not sure, right? And also you can even use this calculator, right? You know that you can integrate like this. Type in the original function alpha x squared. Then you plus 3. My lower limit 0, upper limit is 3. You press equals. I got 18. You can see a 9 plus this is 3 times 3 is 9 as well. Yes, obviously it's 18. You minus 12. Your area should be 6. Okay. Yeah, it's quite long for 7 marks. Right. Okay, next. Find the volume of revolution in terms of pi when the region bounded by the curve straight line y equals to 12, y-axis is revolved 360 about the y-axis. Okay, so where's the region bounded by the curve? Okay, let me just highlight for you. This is the curve, region bounded by the curve. Okay, this is the the curve, the line y equals 12. This is line y equals 12. It's a horizontal line. Yeah, sorry, my line not very straight. Y equals to 12. Okay, and then also I need to have one more y-axis. So your region is actually this, Your region is actually this, and I'm going to rotate 360 degree about the y-axis. So it looks something like that. Actually, the shape is not important. So the more important thing you need to understand that when you rotate about the y-axis, the formula is integrate pi x squared dy, right? And you must put in lower limit, upper limit. Your x squared is now y minus 3. I make x squared as a subject. And you can see for this curve y equals x squared plus 3, your y-intercept is actually 3. So I know I have to integrate from 3 to 12. So your volume will be integrate pi, put your x squared inside, y minus 3 dy, because I'm rotating about the y-axis. Lower limit 3, upper limit 12. Let's take out the pi. Now, you can choose to integrate one by one as in, you do y squared over 2 minus 3y. If you want, you can do that. All right. I personally like to use a composite function. Now, just let me recap. How do you integrate composite function? So even if I have a k outside, yeah, a constant outside, I just copy the bracket, increase the power by 1, divide by the increased power, and differentiate inside the bracket. Right? When you differentiate ax, you should get an a. So I like to use this because it's faster, especially when you substitute. Now, copy the bracket, increase the power by 1, divide by the increased power, differentiate 1y, you get 1. So whether you want to write with the 1 or don't write is okay. It's just going to be 2. So your lower limit is 3, upper limit is 12. Let's put it inside. So this is pi over 2. Put 12 inside. 12 minus 3. All right. It's going to give us 9. Okay, you want, you can do one extra step. Let's just write like this. And 3 minus 3 is going to give us 0. So this is going to give us 9. 9 squared, 81. 81 divided by 2. You can write 81 over 2 pi. Or you can write 40.5 pi unit cube. Yeah, this is volume, so it's unit cube. Moving on to the next question. The next one is section C, index number, form 4, chapter 10. Okay, so here we have a table that shows price indices of 4 motorcycles, A, B, C, D, sold by a company in the year 2009 based on the year 2017. So first part, if the price of model B in 2017 is 5,550, find the price in 2019. Now, if you look at model B, the price index is 105. Okay, so if you want to calculate the price in the year 2019, remember index here, maybe I can write down for you. If again, it depends on how you want to label it, right? So some teachers will tell you use 2019 based on 17 like this. Then we put P19 over P17 times 100. Okay. Now, another way of writing is we write I 17, 19. So I personally prefer to write like this. Okay. This is your base. This is the current. But again, if this is 19, by the way, the 19 looks ugly. Now, by the way, if you don't even write, it's fine. Okay. You don't want to write this, is fine. Because we can just calculate directly. The current year, usually we write below the base year right below, the current year right on top. So the current year in this case is 2019. We're finding the price in 2019. The base year is 2017, which is 5,550. You multiply by 100, your index is 105. Yeah, 105 from the table here. So to find the price in 2019, very simple. Just use your calculator, 105. You multiply by 5550, divide by 100. I got 5827.50. Yeah, 5,827.50. Okay, that is part A. So part B. The price index for model C in the year 2021 based on 2017 and 2019 are these two. Okay, if you look at model C, right, this is the price index, which is B. They gave us the price for this 2 year, 2017, 21 based on 17, 21 based on 19. Now, in this case, we have to use what we call the simplified chain rule. Now, I'd like to represent it on the diagram because it's easier to understand with this diagram. So since we have 3 years involved, my first year is 2017, second year 2019, the third year is 2021. Now, we know the price for P will be the price index of 19 based on 17. That means this is your P. Then 2021 based on 17 is 146.4. 21 based on 17 is 146.4. 21 based on 19, this one 19 is 120. So this is 120. Okay, so to find the value P, now here's the what we call the simplified chain rule. When you have two consecutive indices here, you can take I, the first one. In this case, I think I don't write the formula, but just based on the diagram, it's easier. P, we multiply by 120, you divide by 100. Your overall increase should be 146.4. Yeah, we take the P here, you multiply 120 divided by 100. It's always 100. There's a way to prove it, but you don't need to know the derivation. So divide by 100, you always get 146.4. Yeah, the overall increase from 17 to the year 21. So what I need to do is to use my calculator, take 146.4 times 100 divide 120. So this answer is 122. Okay. Now they ask us to find the value P and describe the changes in the selling price for model C from 2017 to 2019. So basically, when you have an index of 1 to 2, it simply means the price increase. You can say the price increase by 22%, right? You can add in the year from what you said, 2017 to 2019. Yeah. Okay. So remember, anything more than 100 is increase. Anything less than 100 means it's reducing. Okay. Next one, part C. Given the price of model A 2017-19, 6001, 6007, find the value R. Okay, for model A, again, that's quite similar to what we need to find earlier. You're given the two price indices, you're finding the index, yeah? Similar to this price index formula that I've shown you here, this one, right? So your price index for model A is R. The price in year 2019, it was 6710. Price index for 2017 is 6100. You just multiply by 100, okay? So let's take this, 6710 divide 6100, multiply by 100. I got 110, okay? 110 means increase by 10%. Okay, the next thing is I also need to find the composite index. Hence, if the composite index for the price of motorcycle is 116.4, find the value of Q. Well, I know my P, I know my R. My R is 110. My P is 122. Q is the monthly sales here, right? Monthly sales here. So the monthly sales will be your weightage. In this case, this is Q, this is 2, this is 8, this is 7. Quite easy to see. Yeah. Now, I just have to use composite index. Remember, composite index is the sum of IW divided by sum W. Okay, we need to take individual index multiply with the weightage, divide by your total weightage. Okay, so I'm going to write the formula straight away. My individual index, the first one is 110. I multiply by Q. Second one, 105. I multiply by 2. Third one, P is 122. I multiply by 8. Last one, 116. I multiply by 7. Divide by your total weightage, Q, 2, 8, 7. This total is 116.4. Okay, what I need you to do is to calculate all the rest. Okay, now just use your calculator. Take 105 times 2, times 2, plus 122 times 8, plus 116 times 7. Okay, let's count this first. I got 99. Yeah, 1998, sorry. So this will be Q plus 17. The result 116.4. Let's multiply over this is 110Q plus 1998. So this is 116.4Q plus, let's take 17. 17 times 116.4, I'll get this value 1978.8. Yeah, 1978.8. So bring it over. Now take 116.4 minus 110. This is 6.4 cube. All right. 1998 1998 minus 1978.8. So this will be 19.2. Yeah, 19.2. My Q is now, let's take 19.2 divide 6.4. Okay, answer Q is just 3. Okay. Okay, moving on to question number 13. This question 13 is solution triangle, chapter 9, form 4. Okay, now, first of all, you're given a quadrilateral PQRS. Yep. And you're supposed to find angle PRS given that PRS is an obtuse angle. Okay, so PRS is this angle. Now we can see that when you're given a set of angle with the opposite length, angle with the opposite length, with one missing information, the missing information is R. So we can use sine rule to find the value of angle R. So let's start by writing sine of whatever angle you're finding, in this case, PRS, you divide by the opposite length, 13.58. Then you equate it with sine 26.6, divide by the opposite length. My opposite length is 8.599. Now use your calculator. Okay, I'm going to type in here sine 26.6. All right. Make sure your calculator is in degree mode. Degree mode, because sometimes when you do circular measure, you use radian, you forgot to change it back. 8.599. Then you multiply by 13.58. And I got 0.7071. Now, what you need to do is to shift sine answer equals, you should get 45. But remember, PRS is an obtuse angle. So if it's obtuse, we always have to do 180 minus whatever angle I get, because there are two possibilities. When you use sine rule, your angle can be acute, can be obtuse, right? So especially when you get your sine value just now, we actually got sine PRS equals 0.7071. There are two possibilities for PRS. We can be 45, can be 180 minus 45. But since the question already mentioned is an obtuse angle, so let's take 180 minus, your angle here is 135. Okay, so I know this is now 135. Okay, then they say if straight line PR is extended to point M. So I don't know where is it. I just extend all the way like this. Okay, it's supposed to be a straight line. Must look like a straight line here. Okay, still very ugly. Okay, now such that angle RPS is the same as MPS. Okay, that means your M is probably here. RPS, okay, RPS is the same as MPS. They're both the same. RPS, MPS, they're both the same. So M should be somewhere here. And RS is the same length as your MS. So this is also 8.599 equal length, right? So we're supposed to find the length of PM. Okay, so to find the length of PM, actually there are two ways to do it. You can actually find directly, yeah, or you can find the length of PR first, then you also find the length of RM. You can find both, right? And they add up. Well, the thing is later on you will need to find the area of pentagon PQRMR. And we also need to find angle PRQ. And to find angle PRQ, I will need the length of PR. So in this case, I think I'll just find one by one because I know I need to find PR later. And I also need to find RM. Okay, so let's look at focus on PR. Okay, now I already know these two angles. I can find this angle PSR. Okay, let's write down PSR. It will be 180 minus 26 8.6 minus 135. Okay, so just use your calculator. 180 minus 26.6 minus 135. So this will give us 18.4. So this angle is 18.4. Okay, so if I know this is 18.4, I can now find the length of PR. So I can use sine rule. In fact, you can also use cosine rule. I think sine rule is easier. Let's take PR, divide by sine 18.4. Let it be equals to this length here. I like to use, you can use this 8.599 divided sine 26. Or you can even use 13.58 divided by sine 135. Okay, so let me just use 8.599 divided by sine 26.6. Okay, calculator, 8.599 divide sine 26.6. So whatever I get here, I multiply by sine 18.4. Okay, so my PR is 6.062. Yeah, PR is 6.062. Okay, once I know this length, 6.062. Now remember, I know this is 135. I know this is 45. And because these two are equal length, they're isosceles, so this is 45. So if both of them are 45, we know that this is a right angle triangle, right? So if this is a right angle triangle, to find RM, very simple. You can either use Pythagoras actually, or you can use SOHCAHTOA again because it's a right angle triangle, right? So I need to find RM. Remember, I need to find RM so I can find PM. So my RM in this case, I think we can just use 8.599 square plus 8.599 square, since these two are equal length. They are isosceles and it's a right angle triangle, right? So we square root it. Now let's take this 8.599 square. Since they are equal length, I times 2. Whatever I get, square root, answer equals. I got 12.160. You can write 161. If you want to enhance the accuracy, maybe I use 12.161. Okay, 12.161. And I need to find the length of PM. So PM, this is part A, yeah? Roman 1. This is Roman 2. Basically, we need to find 6 PR plus RM, add up. Take this value plus 6.062. I got 18.22. Now, you want to use 223 also can, or 18.22 is also good enough. 18.22 cm. Yeah. More significant figure is good enough. Okay. All right. Next, part C, we need to find the part B. We need to find angle PRQ. Now, based on this triangle PQR or PRQ here, we know the length of 3 sides already. So we need to find this angle. Okay, I like to use the modified version of cosine rule. Now, you know cosine rule is a square equals b square plus c square 2bc cos a. Now, some students, they sub in here and then rearrange to make cos a as a subject. That, for me, I wouldn't do that because when you sub in, there are a lot of decimal, then you got to bring and rearrange it. It's a little bit more difficult. Might as well we rearrange right from the start. I bring this over. I know this will be b squared plus c squared. Bring the a squared over, minus a squared. Imagine this, I got 2bc in front. I divide it directly, 2bc, and this is cos a. I would use this formula directly. It's faster, right? So what we need to do is to find cos angle PRQ. Your B and C, for PRQ, your B and C will be this. Your A will be your opposite length. Yeah, your A will be the opposite length, 12.21. So let's take 6.062. We square it. You plus with 7.813. We square it. Minus the opposite length, 12.21. We square it. Divide by 2AB. Your A is 6.062. Your B is 7.813. I mean, your B and C. Yeah, this is your B and C. So use your calculator, PRQ. Okay, let's do it. Take 6.062 plus 7.813. You square it. you minus 12.21, you square it, and then you divide by 2 times 6.062 times 7.813. Okay, so whatever we get here, press equals, shift cos answer equals. You should get 122.79. Yeah, your angle here is 122.79. All right. So now that I know this angle, we can now find the area of pentagon. All right. The area of pentagon here, pentagon PQRMS. So that means you're finding the whole thing here. We're finding PQRMS here. So it actually consists of two. The first one, of course, is this triangle. Yeah, the first triangle is this one. And the second triangle is, let's say, this one, the whole thing. Okay, now I already know the measurement and the angle here for the first one. So I'm going to use half AB sine C. For the first triangle, it will be triangle BQR. The second one will be triangle BMS. All right, so your PQR, I use half AB sine C. A is 6.062. B is 7.813. Sine of your angle in between, which is this 122.79. For the second one, I use half AB sine C as well. But your AB, in this case, I think you use this. Your AB, I'll use PM here and also BS. So your PM is 18.22. Okay, this is 18.22. B is 13.58 here. 58 here. And then your sine of angle between 26.6. Okay, let's just count. Half, your A is 6.062, B 7.813, and then sine 122.79. Okay, 79. Now, whatever we get, we add with the second one, half. This is 18.22. Second one is 13.58. And then sine 26.6. Okay, my answer is 75.30. Okay, now you might get a slightly different answer because some of you may use 18.23 here. Because if you use 18.23, let's just see. If I just change this to 18.23, right? This is 18.223, actually 18.223, right? Then your answer might be a little bit different. Okay, let's see. Yeah, you get 31. Yeah, you get 75.31. But it doesn't matter. It's because here I'm using 4SF. So when you use 4SF here, right, your answer will be 30. If you use 18.223 5SF, you get 75.31. Okay, moving on to the next question. This is from 5, chapter 10, Kinematics of Linear Motion. So here we have a toy car that moves along a straight line with the velocity given as this. Yeah, v equals -4t plus 56, t minus 160. Okay, you're supposed to find the displacement function and acceleration function in terms of t. Okay, let's start by finding the displacement function. Remember, when you're given velocity, you differentiate, you get acceleration. You integrate, you get back your displacement. So to find the displacement, you're finding both displacement and acceleration. Your displacement function will integrate your velocity. All right, 560 minus 160 dt. So when you integrate this, you copy negative, copy 4, copy t, increase the power by 1/3, divide by 3. Now, when you integrate 56, this will be 56t squared over 2, and this is 160t plus c. Now, you can actually simplify further. The 56 divided by 2 is 28. There's a t squared minus 160t plus c. Now, we know when t is 0, when you start the clock, read the question here, they say, t is time after passing through fixed point O. So when t is 0, what's your displacement? Displacement is also 0 because it starts from point O. So picture this. If I put 0 inside S, inside T, so your C will be 0, right? And your displacement function is now this 28 t squared minus 160 t. Okay. Now, as for acceleration function, we have to differentiate your velocity. Now, velocity function is quite easy. You can differentiate this. Negative 4 times 2 is negative 8t. Differentiate 50, 60, you get 56. Differentiate 160, you get 0. Now, next, part B. The toy car will lose control if it reaches the velocity limit of 40 meters per second. Determine whether in the given motion, the toy car will lose its control. Justify your answer by calculation. So basically, we need to know whether the maximum velocity will actually reach 40. Yeah, if the maximum velocity exceeded 40, meaning it will lose control. Yeah, before it reaches the maximum, right? So to find maximum velocity, remember, when you do a sketch of your velocity time graph, it goes up like this, and you may have a maximum, and the maximum happen, yeah, when your A is 0. This is your Vmax, if you like. It happens when your acceleration is 0. The gradient of your velocity is acceleration. You let A be 0. Okay, so let's sub A with 0, find the time. So bring over 8t is now 56, t is now 7. Take this t equals 7, sub inside your velocity function. Yeah, your velocity function over here. Right, see whether your maximum will exceed 40 or not. So this is negative 4, 7 square plus 56 times 7 minus 160. Okay, let's count. Let's take this negative 4 times 7 square plus 56 times 7 minus 160. Okay, so this answer is 111. Okay, let me try one more time. I think I typed wrongly. Negative 4 times 7 square plus 56 times 7 minus 160. There you go. Okay, my maximum velocity, this is 7. Sorry, this is 7. Yeah, 36. Yeah, my maximum velocity is 36. So here the limit is 40. So that means I would never reach 40, right? So if you never reach 40, means what? The toy car, will it lose control? Yeah, it will not lose its control, right? So you only lose control if it exceeds 40 meters per second, right? In this case, no. All right, next one. During its motion, the toy car stopped twice. So find the total distance traveled between the two stops. Now we know it will stop when your V is 0, right? It stopped instantaneously when V is 0. Let's take your V here, let it be 0. Now, in order to factorize and solve for t, I think it's better we divide by negative 4 to make your number smaller. Now, 56 divided by 4 is 56 divided by 2 is 28. Divide to 14, negative 14t. 160 by 4 is 40. So it's a positive 40 here. Let's double bracket factorize. What's the factor of 40? I should use 4 and 10, right? 4 times 10 is 40 and 4 plus 10 is 14. So both are negative. So t is 4 and 10. Yeah. So we know that the toy car will stop twice. The first time when t is 4, second time when t is 10. So we're supposed to find the distance between them, right? So since I already have my displacement function over here, we can just sub in, right? In this case, I would just say the distance between them is S10 minus S4. But when you do this, right, you may get a negative answer. If you get negative answer, means it's moving to the left, then we just modulus it, all right? Okay, so I'm going to type in my calculator. I'm going to type in the function here, negative 4 over 3 alpha x cubed, right, plus 28 alpha x squared, then minus 160 alpha x. Okay, use the calculate button, calculate. Let's start with 10. I put 10. I should get this value. Okay, you still need to show your working though. Negative 4 over 3. If I put 10 here, 10 cubed, you can write 1000, or you can just write 10 power 3. This is 28, 10 square, 160 10. Then you minus your S3. S4 is negative 4 over 3, 4 power 3, 28, 4 power 2, 160 times 4. Okay, so let's count. Yeah, use this. The first answer original is negative 400 over 3. Negative 400 over 3. Okay, second one, let's calculate and put in 4. I got 832 over 3. This is negative as well. Negative 832 over 3. So when you subtract, you notice that it's basically 832 minus 400. So that's 432 over 3. Yeah? You can actually take 432, divide by 3, or you can leave your answer in as 144. It's an integer, whole number. Yep. So, yeah, not too difficult. Okay, last question, number 15. So this is from 5, chapter 7, linear programming. So here, a fishmonger sells C bus and X kg of C bus and Y kg of grouper daily. He sells C bus at the price of 20 ringgit per kg, grouper at 30 ringgit per kg, kilogram. So the total amount of sale is 1,800. The ratio is at least 1:2, and at most 445 kg of C bus are sold every day. So now we're going to state 3 inequality other than x more than 0, y equals 0. Okay, so I'm going to write the inequality here. The first inequality will be the total amount that he paid, right? So the total amount of sale. So 20 kg times x, grouper is 30 kg times y, that is price per kg. Yeah? You multiply with the mass of the fish that you sold. This must be at least 1,800 ringgit. Okay, now actually you can leave it like this, but for me, when you want to solve, when you draw the graph, right, it's easier if you simplify this to the lowest term. This is actually okay to stop here, but I'm just going to divide by 10 so that for the subsequent part, when I draw the graph, it's easier. This is now greater equals to 180. Okay. All right. My second inequality, Roman 2, is the ratio, right? The ratio of the weight of C bus to the grouper is at least 1:2. So I write x over y is at least 1/2. So let's cross multiply. So this is 2x greater equals to y. But normally what we do, we write y first. So your y is less equals to 2x. Yeah, y is less equals to 2x. So second inequality. Okay, my third inequality will be the at most 45 kg of C bus are sold every day. So x at most means less equals. So less equals to 45. So this one is a single inequality, it's a straight line. Okay, so I'm going to draw a table of values here before we draw the graph. So the first one is 2x plus 3y equals 180. So let's start off with x equals 0. If you replace x with 0, 180 divided by 3, y is 60. If I replace my y with 0, right, 180 divided by 2, I got 90. So we normally take these two because these two represent the x-intercept, the y-intercept. But you can use any other point. All right. So the second one, okay, let me just label this first because we are supposed to sketch, draw on the graph using a scale 2 cm to 10 kg. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90. This will be x value 10, 20, 30, 40, 50, 60, 70, 80. I think 90 is enough, right? So there you go. That's your second y-axis. Okay, let me just use my ruler here to draw the, I need to draw the horizontal axis here. A bit higher. Let me just adjust it. Are you here? Okay, and then continue with another vertical axis. Over here. Okay, now I need to draw the first line, 0, 60. So where is 0, 60? 0, 60 and 0, 60 is over here and 90, 0 is over here. Okay, I think it's okay, right? Yeah, could be better. So this is 2x plus 3y equals 180, the first inequality. Now, the second one, y equals to 2x. So for y equals to x, right? Well, we start off with x equals 0, your y equals 0. Now, I can't do y equals 0 anymore. You have to use another point. Which point is up to you. Maybe I use 30. When your x is 30, y is 60. You can use other value. You can use 40, 80, and so forth. So now I know I have to draw the first line. The first point must pass through 0, 0. Second point must pass through this. 30, 60 is over here, right? But I think maybe we should extend it. Extend, make it a bit longer. Yeah, easier for us to, yeah, because sometimes the graph will be, we need a bit more, a bit higher than this. So you can see 0, 30, 60, it passed through 30, 60 here. You can go a bit higher. So this line is y equals to 2x. Okay, the third line is x equals to 45. X equals 45 is a vertical line. You don't need to draw table values. Yeah, just 45 is over here. So let me draw over here. Let me adjust the line a bit. Yeah. Okay, looks okay. This is x equals to 45. Okay, now that I got three lines, okay? Now the question says you need to construct and shade the region R, right? Now the first one is greater equals 180. That means it must be above this first line. Yeah, above the line. Second one is below y equals 2x. Okay, the first one is above this line. Second one is below this line. The third one less equals 45. So it's inside this region. Okay, so it's up to you how you want to shade it. Okay, for this case, I will, okay, I think I better just use normal shading like this. Yeah, although it looks a bit ugly, right? And label it with the region R. Okay, now next, what I need to do is to find the range of weight of the grouper sold if he sells 30 kg of sea bass in a day. 30, x is 30. You want to find the range of y. So when your x is 30, I'm going to use 30 here. I just use dotted line. Now you can use a ruler and draw. Okay, that means your y value should be between 40 and 60. You're finding a range, so it's anything between 40 and 60 when your x is 30, right? So let's just write down the answer. Okay, so the range of values of y is a grouper, so we say the range would be 30 to 60. Now you can also say 30 to 60 kg. Yeah? It's okay to write in inequality form or even in the range like this. Like in statistics, we write like this, 30 to 60 kg. Okay, right? Sorry, it's not 30, it's 40, 40 to 60. So it's 40 to 60. All right, next, Roman 2. The minimum daily cost, if the cost of a kilogram of sea bass and a grouper are 15 ringgit and 20 ringgit respectively. So here we have to form an objective function representing the cost. So we say 15x plus 20y equals to k. K is your cost. Now you can use letter C if you want C for cost if you like. Now the main thing is to find out, to draw or sketch a line that represents this cost function. So for me, I would change it to y equals mx plus c. Now, some teachers will tell you put two random point, put a random value k. All right, put a random value k, so you can draw a line on this graph here. But for me, sometimes the k value that you choose maybe too big, too small, or bound. So it's actually easier for me if you change this to the form of y equals mx plus c. Because after all, what we are concerned about is the gradient of this line, right? K is affected by your y-intercept. The K value is adjusted. We can go up and down, but the y-intercept is the gradient is very important. The gradient in this case must be negative 15 over 20 is 3 over 4x, and then you plus K over 20. That means this line will have a gradient negative 3 over 4, but your y-intercept is variable. Your y-intercept can be bigger, can be smaller, right? So let's draw a straight line with the gradient of negative 3 over 4. And to draw that, right, the most important thing is that your ratio must be 3 to 4, and it must be downwards. 3 to 4 means like this. Your y-intercept can be 3, your x-intercept can be 4. Now, you can use any other point. Any other point also can. But for me, 30, 40 is the easiest, right? You want to use 60, 80 also can. The ratio must be 3 to 4. This is 4, this is 3. You want to draw higher, bigger, doesn't matter. And an important thing is it must be going downwards because your gradient is negative. Now, let's take this line and shift it up and down. Normally, when we draw this line, actually, we should use a dotted line, but guys, I'm not using a dotted line here. So maybe I just remove this, right? Sorry, my line looks a bit ugly. So I can take this line and I move it up, okay? Move it up, okay? When I move up, I need the same gradient. I need the same gradient, so I'm going to move this up like that, the whole thing. Now, notice that this point will give me the smallest. We want a minimum, right? You want a minimum cost. Okay, my line is still not very good, right? 3 over 4. Which one will give us smallest y-intercept? Now, you have 3 options here. You can put it here. This point here. Very hard to see. This point, maybe the line should be a bit longer. Okay. This point here, it can give us a y-intercept that is here. You can move it a bit higher, this point, but your y-intercept is higher. As long as you can pass through any point on this region, right? This will be your maximum cost. Now we want minimum cost. So you need to move it here. Yeah, we need to choose a point on the graph that gives us the smallest y-intercept. Okay, let me just move in a little bit so you can see it has to pass through. Okay, it has to pass through this point here. Okay, how we draw exactly is actually not so important. Yeah, we don't have to draw like super accurate graph. Okay, the most important thing is that the coordinate must be there. So I'm gonna just draw dotted line here. Sorry for the ugly drawing here. Yeah, it looks a bit ugly, right? So I could probably use the ruler to draw it, right? Okay, so I'm gonna remove this line here. Okay, so it looks like this. All right, so this coordinate will give us the smallest value of k. And to find this coordinate, okay, I can just read from the table or from the graph here. I can see it's about 2345. Looks like 45. 23.45. Now, another way to validate or verify, so sometimes you cannot really see whether which point is a correct point. We can actually try by solving y equals 2x and 2x plus 3y equals 80. Solve it simultaneously, as in we do 2x plus 3 of 2x equals 180. So this will be 6 plus 2 is 8x equals 180. X is 180 divided by 8. So when I take 180 divided by 8, I got 22.5. But obviously we can't take 22.5. All this must be whole number, and 22.5 will be outside. Yeah? We want it to be inside the region, right? So we have to take 23. Now, you can repeat the same for y, but remember, if you find a y value, for example, some people take, I take 23, then I times 2, then I get 46. But the 46 is maybe on the line, but it's not the lowest point. It doesn't give us the smallest y-intercept. The smallest y-intercept you can see is actually 45. Yeah, 45 is still within this region, right? It may not lie on this line y equals 2x, as long as it's inside this region, you will do. Okay, so this is just for you to validate. Okay, now we need to take this point and sub inside your objective function. So this is your objective function here. We know your cost is minimum, all right, when your x is 23 just now, and your y is 45. So your minimum cost will be 15 times 23 plus 20 times 45. Now let's count. Okay, 15 times 23 plus 20 times 45. My answer is 1,245. Yep, 1,245. All right. Okay, I hope you learned a lot from this video presentation. So see you in the next video. Bye.